Hello learners, welcome back to my channel Shraddha's Physics. In this part we will see the probability distribution function. So now let us start our topic, that is the probability distribution function. So first of all consider the function, that is the wave function, that is psi, where this psi we can write this is the function of x, y, z and t. Okay. So this wave function can also be written as, that is from the previous class we have already discussed, this can also be written as equal to sum over n equal to 1 to infinite Cn, this is the coefficient Cn, and the function, that is the eigenfunction Fn of x, y, z, and the exponential minus iota En t divided by h cut, where this En is called the eigenvalue of the function. Okay. So here this psi of x, y, z, t, it can be written as the linear combination of the stationary state. So here the psi of x, y, z, t equal to sum over n equal to 1 to infinite Cn Fn of x, y, z exponential minus iota En t by h square. Suppose this is your equation number 1. It is the stationary state. Let this be the stationary state. It is the stationary state. It is the stationary state. Okay. So the complex conjugate of this equation, so we can write the complex conjugate of the equation 1 can be written as, this is your psi star x, y, z, t, that is equal to sum over, let me write m equal to 1 to infinite Cm star, and here this will be Fn star x, y, z, and here the exponential plus iota Em t divided by h cut. Okay. So this is your equation 2, and equation 1 is the complex conjugate of the equation 2. Okay. So now you can calculate the probability distribution. So you can write the probability distribution. So here our main aim is to calculate the probability distribution function of this stationary state. So the probability distribution, so we can write this probability distribution P of x, y, z, t, that is equal to psi of x, y, z, t into psi star x, y, z and t. Okay. So here if I will substitute this value from the equation 1 and 2, we can write, so simply for the psi of x, y, z, t, we can write this is equal to sum over n equal to 1 to infinite Cn, this is Fn x, y, z into exponential minus iota En t divided by h cut, this is your psi, and now we will write the psi star, that is sum over m equal to 1 to infinite Cm star, and here this is Fm star, that is of x, y, z, and here the exponential plus iota Em t divided by h cut. Okay. So if you will multiply this two term, so we can write also that is equal to sum over. So here first of all you can see one is from n equal to 1 to infinite and another is from m equal to 1 to infinite. So first of all we will consider the term when m equal to n. First of all we will write for the term when m equal to n, and that after we will write when m is not equal to m. So this is your sum over n equal to 1 to infinite Cn, and here the Cn star for the second term we can write this is your Cn star when m equal to n. So if I will write here, this is m equal to n. So Cn star Fn x, y, z, and from the second term we can write this is your Fn star x, y, z. This is your first term, plus. For the second term we can write this is your plus sum over, let me write it here, this is your plus sum over, this is your m and n, they will vary from 1 to infinite, that is here we will consider when m is not equal to n. Okay, for that here the cn, and here it will be cm star from the second term, fn xyz and fm star xyz, this is fm star xyz from the second term, and here we can write combiningly exponential iota em minus en whole into t divided by h cut. Okay, so from this term this is your minus ien, and from this term this is your plus iem, so combiningly we can write this is your iota whole into em minus en into t divided by h cut. Okay, so in the second term m equal to n are excluded, so simply we have written here this is from mn equal to 1 to infinite where m is not equal to n. So this is called the probability distribution function of the stationary state solution. Okay, so here we can write in the equation 1 means this is your, when we have considered the function psi of x y z t equal to this much. So in equation 1 we can write, let me write, in equation 1 the term f of, that is fn of x y z is a particular solution of, it is a particular solution of Schrodinger time dependent equation, and this represent the stationary state solution, because the stationary state solution because the psi n into psi n star, that is the probability distribution, that is equal to fn into fm star, it is independent of time, Okay, so this is all about the probability distribution function. Okay, so that's all for today. Thank you all.